Miami Beach is not a hill by the sea. It is a barrier island, a low ribbon of sand and fill, laid down only a few feet above the water that surrounds it on every side. To see how low, we do not have to imagine a flood. We only have to raise a number. This is the ground itself, measured by laser from an aircraft. Every road, yard, and swale to 1/10 of a foot. Watch the color fill from the bottom up. At just over 1.5 feet above sea level, the lowest ground is already coloring in. The gutters, the driveways, the pockets beside the buildings. At about 2 feet, the drainage wells that are supposed to protect this property sit right here, their tops at roughly 2 feet above sea level. And at 2 feet, the streets are already filling in around them. At 2.5 feet, the low spine of the neighborhood is underwater, in color, and we have not yet reached the height of an ordinary high tide plus a heavy rain. Now let the level fall and see what is left behind. As the color drains away, the last places to give up the water are the lowest places. And they are exactly where the water goes when it rains, and exactly where it pools when the tide is high. These blue and purple hollows are not a prediction. They are the shape of the ground today. Speed it up, and the lesson is stark. From 1 foot to 5 feet, the island does not flood gradually. It fills. By 4 feet above sea level, a level that a king tide and a summer storm can reach, more than 80% of this ground is at or below the line. On a barrier island, high ground is a matter of inches, and here is the problem the color cannot drain away. The tide. In these waters, the average high tide stands near sea level, often higher than the lowest ground, and the wells set into it. When the water outside is higher than the ground inside, there is no downhill left. The wells cannot push water into an aquifer that is already full. This is how low Miami Beach is. Not a story about the future, a measurement of the present, 1/10 of a foot at a time.